binomial distribution. It's the binomial distribution. Guys, we are in for a treat today, ladies and gentlemen. The bee's knees, the binomial distribution here. And a binomial setting. 6-3 is all about binomial, and then we talk about geometric towards the end. So let's not haver anymore. Let's get going. And what is a binomial distribution? All right, well, how do we know something's a binomial distribution? First of all, we have a little acronym to help us remember. All right, it's called the bins. Okay, that's different than the bends. All right, the bends is when you stay underwater too long. Seriously, if you check it out, it's bad deal. Bends, bad deal. Bins, good. Bins. Okay, so bins is short for, first of all, B. It's binary. All right, that means you have two outcomes. You can either have a success or you can have a failure. Okay, flipping a coin, you can either have heads or you can have tails. What's another? Gender, male or female, right? You can only have two outcomes: hit or miss. Okay. So that's what binary means. So when we get into a binomial distribution, bi means two. So you should think, all right, first of all, there's got to be two outcomes total. All right. Next thing, they must be independent. Okay. One must not affect the other. Like flipping a coin. Does one coin affect the flip of the second coin? No. Right? Okay. They have to have a set number. Now, be careful because this is different for geometric than it is for binomial. So binomial has to have a set number before we start. So for instance, maybe we want 6 trials. If we do it 6 times, what's the probability it'll happen 4 of the 6 times? Alright, there has to be a set number. Can't be just like, what's the probability it'll happen 4 times? Okay, out of how many? Okay, you need to have a set number. And then finally, the success. On each trial, the probability of success must be the same. So I guess, for instance, let's say when we're taking a test, and let's say questions 1 through 3 are multiple choice, and they have a 25% chance of getting it right? But then questions 4 through 9 are true and false, and so those are 50% chance, right? So yes, these are binary, right? Because you could either get it right or wrong. However, it does have a set number because there's 9 questions. Does one question affect the other? The answer, I mean, hopefully, if you answer A on the first one, doesn't mean the second one is not going to be A, right? But your successes would be different because for the first 3, it's 25% chance, but for this next several, you have 50% chance. So the successes all need to be the same. All right. So for instance, flipping a coin 10 times. All right. You have a 50% chance every time. Okay. You're not going to change those odds afterwards, and that kind of also has a little bit to do with independency too, because independent things are going to have the same. All right. So let's keep going. And here's a situation we're going to come across. Hey, did Graham go down all right? Good. All right. So here's a situation of a binomial distribution. Each child of a particular pair of parents has a probability of 25% of having type O blood. This is due to those crisscrossy things. What are those crisscrossy things in science, Scarlett? Yeah, it's a table. It's like a two-way table. You guys know what I'm talking about. Okay, she'll come back to me. Trust me, she always does. All right. So genetics says that children receive genes from each of the parents independently. Ooh. So all right, that's one of our key things, right? If these parents have 5 children, so a set number, cool, set number, 25% chance, so of having it, and a 75% chance of not having it. The count of X children with a type of O blood is binomial random variable with N is 5. Probability is 25. Success in each trial. It's not going to change as kids are going along. All right, what's the probability of having 2 kids having O blood? All right. So, probability of having 2 kids with O blood would be 1/25, right? And I want another kid. Maybe I'm not going to do that. We'll use parentheses. And I want another kid. So that would be the first kid. Here's the second kid. You guys ready? Woo! They got it. And then the other kids are going Punnett square. There we go. See, I told you she was going to come back to me. Ooh, baby, come back. We've already had one song, Scarlett, in this episode. Don't try and distract me anymore. It's a circle life. This takes forever. All right. So, basically what I got here, would you guys agree? I have 2 successes, right? Here's the first kid, here's the second kid, and then the third kid doesn't have it, the third kid doesn't have it, and the third kid doesn't have it. If I multiply those together, I get my answer, right? Well, you're working towards it, but not all right, okay? Because with this situation, is hopefully you realize there are multiple ways, right? There's more than just one way to have kids. This would be the event if the first 2 kids had it and the last 3 didn't have it. Oh my goodness. Why did I write 3 on all of them for? Okay? Does that make sense? So this would be the event only the first 2 would have it. Alright? But there's other ways I could have 2 kids have it, right? Maybe my first 2 don't have it. My last 2 could have it, right? So this is just one way this event could happen, all right? So let me just let's go back now. What's the probability of them all having it? All successes. Well, that would be 0.25 times 0.25 times 0.25. Remember, there's 5 kids. All right. Times 0.25. Oh yeah, we're going into multiple lessons on this guy. Times 0.25. Okay? This would be the event that all of them had it. And if I multiplied those together, that would be the right answer, because how many ways can all of them have it? There's only one way all of them can have it. Right? Only one way. Okay. But with 2, I could mix match these all around. So here's all the different ways 5 kids can be arranged, or 2 can have it with 5 kids, right? So the first 2 could be successes, or maybe the first one, the third one, the first one, the fourth one, and so on and so forth, right? Okay. Well, I don't know about you, and I think I've told this to my AP Stats class. This is like my least favorite thing to do, is list out all the sample spaces. Like, oh, shoot, because I know I'm going to miss one, right? So, here's the deal. If this is one way it could happen, I just need to figure out how many ways it can happen and multiply this by how many ways it can happen. Does that make sense? Because that's one way how it can happen. What are all the ways it can happen? So here's the beauty, all right? Here's the beauty. We got a formula. We got a formula for this. I don't even know what we're talking about here. This doesn't make even sense. This doesn't make sense. Oh, because there's 10. There's how many ways? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 of these. So we're going to multiply this times 10. I gotcha. I got what they're drifting at. And if I multiply that times 10, that's going to be the answer. So it's going to be 0.263. All right, if I multiply, so there are 10 of these guys right here, and that will list out the whole sample space. So the probability that 2 will have it is about a 26% chance. Now here's the best part, is there is a way to figure out how many outcomes there are without having to list out all the spots. All right, wait for it, wait for it. It's called a combination. All right, now I'm going to just show it to you on your calculator, and how you can do this on your calculator. Oh, I'm hiding myself. There we go. All right, so what you're going to want to do is you're going to want to go to math over here. See the math button, and go all the way over to probability. Okay, and then right here there's this NCR. Now, depends on what kind of calculator you have in the settings, but that is going to be your combination button. Now, I didn't put anything in there first, so I'm going to say, all right, well, there are 5 kids, so I'm going to put in 5 first. Oh my goodness, 5 first. Then I'm going to go over to that math and over to probability. NCR, because this is going to be combination, by the way. If you're worried about combination permutation, we never do anything with permutations in AP statistics. We never do anything with permutations in AP statistics. It's all combinations. So you're going to have at the NCR now. So that means 5, and I want how many successes? I want 2, and if I hit enter, I should get 10, right? How many different ways can those be rearranged? Boom. Just feast your eyes. All right, so there are 5 total kids. I want 2 to have it. Boom, all right? So without having to list out the whole sample space, I got it. Okay? So that's really the quick and dirty of this first section. All right? Now, they give all this kind of weird thing. This is the big formula for it. If you wanted to calculate it by hand, you can calculate it by hand, but I've never really ever done it by hand. This right here is the same thing, and maybe you want to write this, equals, it's going to be N capital C-K. All right? N capital C-K. And that is what will be how many ways something can happen. So I wish it would say combinations. I said this is also known as combinations in your calculator. We have, I think NCR is what's in the calculator, but they use acronyms NCK. All right, so that's basically what a binomial distribution is really like. I got 2 more minutes. Let's see if I can maybe knock out one. They have a shortened formula. Remember, this is the N capital CK, right? And then we take our probability of our successes. So, for instance, our case was 25. So how many did we want to have successes? We wanted 2, right? This is just kind of shorthand. And then how many failures did we want? Well, failure is 75%, and that's what that 1 minus P means. This means the inverse. And then if there's 2 successes, how many must be failures? 3, right? So this is just kind of shorthand of how it works. If you want to write it all out in a long line, go for it. Whatever kicks your giggles. All right. Each child of a particular pair, okay, we'll find the probability exactly 3 of the children have O blood. All right, we're really moving on now, okay, really moving on. So we want 3 to have O blood, so I'm running out of time, guys. We might have to pick this up next episode. All right, in fact, I'm going to pause it. All right, so as I wrote this out, I have 3 successes and then 2 failures. So remember, but this is just going to be one way, right? Well, how many ways can I have 3 successes? And so I'm going to do this NCR again here. I'm going to have 5 math probability over to NCR, and I want 3 this time. And if I hit enter, I've got 10 again of these. So I really have 10 of these. And so when I multiply, whatever this answer is going to be multiplied by 10, because there's 10 different outcomes. Okay. So we're going to pick up where we leave off, and don't leave.